So, you've learned the code, right? You get the syntax, you've got the concepts down, but how do you actually build something? If you've ever just stared at a blank file totally stuck, then you're in the right place. We are going to bridge that exact gap starting right now.
I bet this sounds familiar. You know what a variable is, you totally get how loops work, you can even write a pretty good function, but the second you think, okay, I'm going to build a to-do list app, you just freeze. It's that jump from doing little practice exercises to building a whole working project that trips so many people up, and believe me, it is a super common hurdle.
But here's the thing. What if you had a map? You know, a repeatable framework, a kind of blueprint that you could use for any console app idea you come up with? Well, that's exactly what we're going to do. We're going to lay out a simple 4-step blueprint that'll take you from a blank screen to a finished program.
Okay, so step 1, and honestly, this is the most important step of all, the blueprint. Before you even think about writing a line of code, you have to plan. See, great programs aren't just coded, they are designed.
And the secret to good planning? It's all about breaking a big, scary problem into tiny, manageable pieces. There's a fancy word for this, decomposition. But really, just think about it like this. You wouldn't try to build a whole car in one go, right? No way. You'd start with a wheel, then maybe an axle, then the frame, one piece at a time.
So let's get practical with our to-do list app. What does it actually need to do? Well, a user should be able to add a task, view their tasks, mark one as complete, and maybe delete a task. Boom! Right there. Those are your main features. And guess what? Each one of those is probably going to be a function in your code. You also got to think about the user flow, how they'll navigate around. And what about weird stuff, edge cases? Like what happens if they try to view tasks but the list is totally empty? Thinking about that stuff now will save you a massive headache later on.
And this right here, this is the heartbeat of pretty much any console app. It starts up, shows you a menu, waits for you to pick something, does the thing you asked for, and then loops right back to the menu again. It just keeps doing that over and over and over until you tell it, hey, I'm done, time to exit.
All right, we've got our blueprint. Now it's time for step 2, the build. This is where the rubber meets the road, where we start turning that awesome plan into actual working code. Let's build this thing's engine.
Right at the very heart of our program is what we call the main application loop. It's literally the engine that keeps the whole thing running, just waiting and listening for what you want to do next. I mean, without it, the program would just run one line of code and quit. Not very useful, right?
So how do you build this always-on engine? You're going to love this. It's actually super simple. In a language like Python, a while true loop does the trick. It creates a loop that, you guessed it, will run forever, unless we give it a specific command to break out. This little piece of code is the core of that flow we just talked about.
Okay, but a program needs to remember things, right? It needs a memory. For our to-do list, we've got to store the tasks somewhere. And a list of dictionaries is a fantastic choice here. Think of it like a filing cabinet. The list is the cabinet, and each dictionary inside is a folder for a single task. That folder can hold all the details, like the task description and whether it's been completed or not.
Okay, great. The code works, it functions, but is it actually nice to use? That brings us to step 3, the polish. This is where we stop thinking just like a programmer and start thinking like a real person using our app. And trust me, a little bit of polish goes a very, very long way.
Just look at the difference here. A prompt that just says input. What does that even mean? Input what? My name, a number? It's useless. But enter the task description. Now I know exactly what to do. It's such a tiny change, but it completely transforms the experience from frustrating to, oh, I get it.
And what about when the user messes up? Because they will. What if they type out the word 1 instead of the number 1? A badly made program just crashes. It throws up a bunch of scary error text and dies. But a good program sees that coming. It catches the error, says something helpful like, whoops, please enter a number, and lets them try again. That's the difference between a fragile little script and a really solid application. And here's a golden rule. Always give feedback. When someone adds a task, don't leave them guessing if it actually worked. A simple message like, task added successfully, is huge. It gives them confidence and tells them, yep, I heard you and I did the thing.
All right, we've built the engine, we've polished the exterior, now it's time for the last step, the test drive. Listen, nobody's code is perfect on the first go, ever. The real magic happens when you start testing, finding what's broken, and making it better. And to be a good tester, you need to adopt a certain mindset. You have to ask, what happens if I try to
Be curious. Be a little bit evil even. Don't just check that it works when you do everything right. No, you need to actively try to break it. Think of the craziest things a user might do.
We call these edge cases, the stuff that happens at the fringes of normal use. Like, what happens if I try to delete task number 99, but I only have 5 tasks? Or what if I enter letters when it's asking for a number? What if the list is empty? A really solid program has a good, graceful answer for every single one of these. And the only way you find those answers is by testing for them.
And that's the whole process. Blueprint, build, polish, test drive. See? It's not just a random set of instructions for one little to-do list app. This is a powerful, universal tool that you can use on your next project, and the one after that, and the one after that.
And look, this blueprint fits any project. Want to build a simple calculator? Cool. You'll plan the math operations, build the logic, polish the input prompts, and test for things like dividing by 0. What about a number guessing game? It's the exact same process. Plan the game's flow, build the main loop for guessing, polish the higher or lower feedback, and test what happens when the user enters crazy numbers.
So, if you take away just one thing today, let it be these 4 steps. Blueprint, build, polish, and test. This is the framework that takes the mystery out of it all. It's that bridge we talked about, the one that finally gets you from just knowing a bunch of code snippets to actually building something complete and useful.
Look, this was never just about learning. It's about creating. You have the blueprint now. You have the framework to take any idea in your head and make it real. So, the only question I have for you is, what are you going to build first?